All right, getting right into it then. Today we are taking a deep dive into linear regression. Looks like someone's been doing their homework, notes from a lecture, and, well, from the looks of it, there were some interesting audio moments in there.
Sounds like someone's been digging into some fascinating stuff.
Yeah.
And linear regression, way more exciting than the name might have you think.
It really is. It feels like once you start to get it, you see it everywhere. So, for all of us who haven't been living in a world of scatter plots and best fit lines, what's the quick explanation of linear regression? The core idea.
Well, imagine you're trying to find a hidden relationship, like how one thing might influence another. At its core, it's about using data to find that relationship, to figure out the story the data is telling us.
So, if our data points were like breadcrumbs, we're using linear regression to retrace someone's steps. No.
Exactly. Except instead of just guessing, we're using math to draw a line, that best fit line, that represents the relationship shown by the breadcrumb trail. And the math helps us minimize those errors, like minimizing the wrong turns we might take if we were just guessing where the breadcrumbs were leading.
I like where this is going. Now, in your notes, you highlighted simple and multiple linear regression. What's the difference?
Think of it this way. Simple linear regression is like a walk in the park. One independent variable, let's say the amount of sunshine a plant gets each day, predicts another variable, how tall that plant grows. Multiple linear regression is where things get more complex, more like navigating a busy city. Think predicting something like house prices, where you have to think about all sorts of different things that impact the price, square footage, location, and those trendy features everyone wants.
Okay, that makes sense. Now let's talk about those Greek letters, like theta 0 and theta 1. They always trip me up a bit. What are those all about?
I get it, those can seem a little intimidating at first, but they're actually really useful. Think of it like this. We're trying to figure out our recipe, and those thetas tell us how much each ingredient matters. Like, if we stick with that house price example, theta 1 might show us how much the price changes for each extra bedroom. And theta 0, well, that might show us the baseline cost, maybe the value of the land itself.
So they're like our secret decoder rings to unlock what those lines we're drawing really mean in the real world.
You got it. And get this, you don't need to be some math genius to figure these values out.
Wow.
We use something called least squares. Now, it sounds a lot scarier than it actually is. Essentially, it's a way to find the line that gets us as close as possible to all our data points, kind of like minimizing those errors we were talking about earlier.
Hold on, errors. We can't just throw that word around like it's nothing. What do we mean by errors?
You're right, that's super important. So, picture that best fit line we drew through all those data points. Each error is like a measure of how far off we are with our prediction for that specific data point. So the distance from the data point to our line, the closer those points are to the line, well, the better our line is at representing the relationship shown in the data.
Okay, I think anyone listening can appreciate that. So we have this line, and those errors, or residuals, as I think I heard in that lecture audio, are basically telling us how far off we were with our prediction for that specific data point. But what happens when our data points are just all over the place? What if they don't really follow a line? Can we still trust linear regression then?
Well, that's where things get even more interesting. Linear regression is a great tool, don't get me wrong, but it's not always the perfect solution. Sometimes the relationship between things is just more complicated than a straight line.
So how do we know if we're trying to fit a square peg into a round hole? How can we tell if linear regression is the right tool for the data we have?
That's where our residuals come back in. Those residuals, or errors, those tiny measurements of how far off our predictions are, they can tell us a lot. If they seem random, scattered all over the place, that actually means our model is probably doing a good job capturing the overall relationship.
Like going back to that breadcrumb analogy, our breadcrumbs are scattered around a bit, but generally they still outline a path.
Exactly. But if we start to see a pattern in those residuals, let's say they're consistently higher at one end of the line and lower at the other, that's a sign that something's off.
Like those breadcrumbs are starting to form a totally different shape, telling us we might have missed a turn somewhere.
Right. That pattern in the residuals is like a red flag, telling us that maybe the relationship between things isn't a straight line after all. It could be curved, or there might be other things influencing our data that we haven't even thought about.
So when we're analyzing residuals, we're putting on our detective hats, looking for those clues that our trusty linear regression model missed.
You could say that. And depending on what those residuals tell us, we can figure out if we need a different approach, a different tool for the job. It's a bit like choosing between a sports car and an off-road vehicle. You wouldn't take a sports car off-roading.
This is really making me appreciate how much information those residuals can give us. They're more than just leftovers from our calculations.
Definitely. Think of them as little whispers from the data itself. They can tell us when we need to dig a little deeper, refine our understanding. Speaking of digging deeper, I remember you were curious about something in the lecture audio. Something about using linear regression to understand customer behavior.
Yes. It seemed like a big jump from something like predicting house prices to trying to understand how people make decisions.
It might seem like a big jump, but it's a great example of just how versatile linear regression can be. Think about it this way. A company wants to understand how different factors, things like their website design or maybe the discounts they offer, all influence their sales. So they gather all the data and use linear regression to see if they can find a relationship.
So they're moving from guesswork to using data and linear regression to figure out what actually makes customers tick.
Yeah. And here's the best part. They can even use it to try to predict what customers might do in the future. Like, let's say their model shows them that changing the layout of their website leads to way more sales. They can then use that to their advantage, make changes, improve their site, and hopefully boost those sales.
That makes sense. So it's like those breadcrumbs, we're not just trying to figure out where someone's been, but where they might go next.
Exactly. And this can apply to so many different things, from predicting how stock prices might change, to understanding how effective marketing campaigns are, even to tracking how diseases spread.
Linear regression is starting to sound like the Swiss Army knife of data analysis tools. So for anyone listening who wants to learn more about data analysis, what's the key takeaway about linear regression? What should people keep in mind when they come across it?
I'd say the next time you read an article or see a study about, well, really anything with data analysis, don't be afraid to ask yourself, could linear regression be involved here? Because more often than not, it is.
It's like that aha moment when you realize the answer was right in front of you the whole time. So if you're listening and you come across a graph showing trends or predictions based on data, think back to this deep dive. You've got the knowledge now to understand what linear regression is and how it's being used all around us.
And remember, this is really just the tip of the iceberg when it comes to data analysis. There is so much out there to discover.
Now, that's something I'd love to dive into more. But until then, keep those brains working and never underestimate the power of a simple line. Sometimes the most elegant solutions are the simplest ones.